So what we have over here is 2 points. The position vector of 2 points are given, and the line AB has vector equation. So basically this line AB is the line L. They usually call it L. Now they're calling it the vector equation of the line that passes through AB. So this is what's happening. So we have a line that passes through AB, and they're calling this the vector equation of the line. Let me call this L. So first of all, we have to find a constant. Remember, for finding a particular point, if a point lies on a line, the value of lambda for that particular point is same for every coordinate. Okay, so let's write this in the ijk format. So 5j, so I is 0, so this is going to be 0 plus 2 lambda I plus, so 5j plus lambda j, 5 plus lambda j plus 11k plus 5 lambda k, 11 plus 5 lambda k. So this is the universal position vector format for L1 or line L. So we have OB. So OB has CI plus DJ plus 21k. We don't need OA over here because we know all the coordinates of OA, 5j plus 11k. But we are asked to find the value of C and D. So for that we are using this. So what we can do here is we can find the value of C by comparing the coefficients. So for I equal to I, C is unknown, J equals to J, D is unknown, and K equals to K, we can find the value of lambda. So for K equals to K, we can write 11 plus 5 lambda equals to 21. Therefore, 5 lambda equals to 10. Therefore, lambda equals to 2. Since we know that lambda is the same for each coordinate, if lambda equals to 2, we can write for I equals to I, it would be 0 plus 2 lambda, meaning 2 into 2, 4, equals to C. Therefore, C equals to 4. Then for J equals to J, we can say the coefficient of J is 5 plus lambda. That means 5 plus 2 equals to D. Therefore, D equals to 7. So we know the value of C and D. It is 4 and 7. Now the same question can be done in another way, in the column vector way. Let me show it in this way. So this is the alternate method. So what we do is we write down the universal position vector, meaning line L, in the column vector format, and it turns out to be 0 plus 2 lambda is 2 lambda, 5 plus lambda, and 11 plus 5 lambda. And we also write the position vector of B in the column vector, and this turns out to be C, D, and 21. And we solve the equation like this. If they're intersecting, we can write 2 lambda, 5 plus lambda, 11 plus 5 lambda equals to C, D, 21. And then we can solve it. So, 11 plus 5 lambda equals to 21. Therefore, lambda equals to 2. And so 2 lambda equals to C. Therefore, C equals to 2 lambda, meaning 4. And D equals to 5 plus lambda, meaning 5 plus 2 equals to 7. So we can also do the same question in the column vector format. Next, we have the same question, the point P. It's a pretty common question. So we have a point P that lies on the line passing through AB. Let me call that line L. So we have that point, and so we have to do this. So this is the line L, and this is the point P, and it is perpendicular to the line L. So it lies on that line, and it is also perpendicular. The position vector of that point is perpendicular. So the dot product of the line L and the direction vector itself, so they should be dot product is 0. So when we want to find the rule for perpendicular, if two lines are perpendicular, their dot product should be equal to 0. So first of all, what is OP? OP is the same as the universal position vector, because remember the definition of this line is for any position vector lying on this line, it's given by this thing. So we can write OP equals to 2 lambda, 5 plus lambda, 11 plus 5 lambda. This is OP. And remember the direction vector of this line L. So it's given over here. This is the direction vector right after the scalar quantity. So 2i is 2, j is 1, and 5. So this is the column vector format of the direction vector of the line L. So for the rule for perpendicular is that the dot product is 0. So 2 lambda plus 5 lambda, 11 plus 5 lambda dot 215 equals to 0. So dot product means multiplying the coefficient of I with coefficient of I. So 2 lambda into 2 is 4 lambda. 5 plus lambda into 1 is 5 plus lambda, plus 11 plus 5 lambda into 5 is 55 plus 25 lambda equals to 0. So this is 4 lambda plus lambda is 5 lambda, 5 lambda plus 25 lambda is 30 lambda, and we have 5 plus 55 is 60 equals to 0. Therefore lambda equals to minus 60 divided by 30 is minus 2. So we have to find the position vector. So OP equals to 2 lambda, lambda is minus 2, that means minus 4. 5 plus lambda, 5 minus 2 is 3. 11 plus 5 into minus 2 is 11 minus 10 is 1. So we can either write it in this way or you can write it in the IJK format. Minus 4i plus 3j plus k. In the final question, we have to find the area of a triangle OAB. So this is how it is working. We have this line A and we have B, and somewhere around here suppose we have P. So we know OP is perpendicular. OP is perpendicular. That was just the previous sum. So in order to find the area of OAB, we can write area equals to length of AB, which is the base, multiplied by the height, half into base into height. So half into base is the length of AB, and height is the perpendicular OP. So the first thing we have to do is find the length of AB, and then we have to find the length of OP. So OP is going to be simpler. So OP, it's modulus of vector. So that is going to be minus 4 squared plus 3 squared plus 1 squared. And this is going to be 16 plus 9 plus 1, which is square root of 26. Now we have to find the length of AB. First of all, AB equals to OB minus OA. So we know what OB is. So OB is going to be 4, 7, 21 because C is 4, D is 7, and 21 is the coordinate of K. So now OA is also given. So it should be over here. So position vector of A is, so I is 0, 5, 11. So this is 0, 5, 11. So AB turns out to be 4 minus 0 is 4, 7 minus 5 is 2, 21 minus 11 is 10. So the modulus of AB, that is the length of AB, is square root of 4 squared plus 2 squared plus 10 squared. So 4 squared is 16, 16 plus 4 is 20, 10 squared is 100, 120. So area is going to be, so area of triangle OAB, half into base, which is square root of 120, into height, which is square root of 26. So let's see what the value turns out to be. So half into square root of 120 into square root of 26. It is 27.9.